Alright, we are doing our second presentation on Manny as a long jumper. I'm Shay Rayburn. Sarah Tulsa.
I'm Hannah Nelson.
I'm Manny.
And the reason we are dressed like this today because we are grad students who are quarantined in their own rooms due to the coronavirus.
So, just in case you forgot, for the patient profile, I am Emmanuel Ifan. I am 6'2", I weigh 260 pounds. Our sport that we're doing is track and field, and more specifically, we chose long jump. The surgery that I had was on my lateral meniscus, my left knee. They just took the whole thing out. And right now we are 3 weeks post-op in this specific simulation. And the goal is for me to be 100% for postseason.
And to even benefit the type fibers that we are using.
These are not all of the systems used, but we're going to go over the two anaerobic, the ATP-CP system, glycolysis, and the two aerobic, Krebs cycle and long-term transport chain.
Alright, so since everyone's going to have access to these videos, we're not going to show them right now, but kind of the purpose for the back view and the front view is the one we showed in the first presentation, which is where Manny is doing broad jumps, and that showed that he was lacking proprioception in both legs. We also have a video here, a link to a video where you can see what an actual long jump would look like, and that's where we want Manny to be by the end of this training.
So the ATP-CP system is actually just a really short burst of energy that can take up to 10 seconds, though our activity is not likely going to go that far, and it does not require oxygen.
Alright, so we specifically chose glycolysis because the ATP system is not able to keep up because there's only one ATP that is being produced. It breaks down and splits the glucose molecules, and the pyruvate becomes lactate when oxygen is absent, and it is taken to the Krebs cycle in the presence of oxygen, and then the net glycolysis is responsible for 8 ATP.
So the Krebs cycle is not the most actively used. It's used in the reload stage. It happens in the mitochondria where the pyruvate enters and is converted to acetyl-CoA. It produces 24 ATP total, but 12 per cycle, and there's 2 full cycles that are produced. It transfers electrons to the ETC, and it removes carbon dioxide. This is a cycle that can be used longer because oxygen is involved.
Alright, so now we have the electron transport chain. It's located within the mitochondrial matrix. And the 5 cytochromes accepted through this is CLQ, B, C1 and C, A and A3. And this pumps protons into the matrix as well as used for ATP, which drives synthesis, and it makes it very efficient because it produces a lot of ATP.
And the systems being used are the ATP-CP system and glycolysis, and we already explained them, but it's for the quick motion we're going to be doing.
So training overview, we did a creatine supplement to speed up the ATP-CP system. In between each workout, 2-minute rest max, and this is because when you are performing the long jumps, you don't know how long you might have between jumps. The goal is to get the glycolytic system maximized, and they are going to be doing bursting activities at high intensity.
So for our sport-specific training, yeah, we chose this for sport-specific, but we also chose these workouts or these specific items here to also train the systems that we're using. So we have a HIIT and interval training for 2 to 3 days a week. We're doing 5 by 10 second bursting sprints, 5 by 10 springboard onto mat jumps, and what that is, you know, when you see gymnastics today run to get onto or to jump onto the springboard and flip and stuff. I'm obviously not doing that, but it's kind of the same motion. And what I'm going to be doing is I'm going to be taking off and just landing onto a mat. This takes pressure off my knee, and I'm not landing on like a super hard surface. And then we'll finish with a circuit with 45 seconds on, 15 seconds off for rest. It's meant to be explosive, so we're doing weighted box jumps, bungee runs, and standing long jumps.
And as mentioned in the slide before, we are going to try to bring in like the 2-minute rest at max, because they have a different range of rest between jumps in an actual competition or practice.
So now we're going to move on to the muscle contraction, which is everyone's favorite. So in the presynaptic nerve, calcium is released down here, which binds to these vesicles, which contain acetylcholine, which then it moves down to here, where it's then released into the synaptic cleft and causing these little red dots, which is acetylcholine, to bind to the motor end plate. And this causes sodium to go in and potassium to go out, which causes a depolarization, also known as an end plate potential. And then causing this motor end plate to shift this way, causing it then to move over here to the Z line, where it enters the sarcoplasmic reticulum, and again, calcium is released to open binding sites on the actin, which is troponin C, and then the tropomyosin moves away, and the myosin then binds to the actin, causing it to contract towards the M line, and that is the whole anatomy of the muscle contraction.
And for the types of muscle contraction, we are going to be using both the concentric and eccentric. For during the activity, there is going to be shortening and lengthening of it within that short amount of time that they will be doing the activity.
So the muscle fibers, we are obviously not using type 1, because this is not a slow event. It's very fast and explosive. For the actual event itself, we're going to be using type 2A, simply because you are taking off and you need to get to full speed, and then you're taking off from the board. And then we're using type 2B as well, more specifically during the warm-up and during our planned workouts and exercises that we have.
So for our strength training and to improve this recovery, we wanted to stick with lots of reps, not a bunch of sets, to focus on the drive that he's going to be using during the actual long jump. So the pause squats and these step-ups are going to get his legs into that driving motion of taking off, whether one leg or 2 legs. Then we're also wanting to do the front raises and the running motion, which is literally the running motion of your arms, to get that driving force with the arms as well, since they are being used to push yourself even farther. And all of these are supposed to and are going to help with the concentric and eccentric contractions that are going to be used. Plus, we're bringing back in the creatine, which is going to help improve him recover quicker between with the less amount of time to rest, and just help him all around.
And then the article that I found was over the effectiveness of open kinematic chain exercises and closed kinematic chain exercises, and how both of those can improve the strength and the recovery from a lateral meniscus tear. Well, it was more just a meniscus tear, not necessarily lateral, but what was found during the study was that they both improved strength, but open kinematic chain was more focused on the strength, where closed kinematic chain was more focused on stability.
And the link can be found in the bottom corner of this slide. And even though we're virtual, questions?